A lot of programming is about repetition. You want to do the same task over and over again. Now, in this chapter, I'm going to find ways of performing repetitive actions using Object Pascal. I'm going to look at for loops, while loops, and repeat loops. To start off, I want to examine a particular programming problem. Now, when you're dealing with strings and characters, you often need to work out what code corresponds to which character. Each character has its own numeric code. The traditional codes were called ASCII codes. These days there are extended character sets and they are defined in what's called UTF-8. But I want to stick to the simpler ASCII code characters for now. You can find many ASCII code charts online. Here's one example. You can see that the first code is 0 and it goes up to 127 in the standard ASCII chart. Not all of those characters are printable. Some are special characters such as backspace and carriage return. And then there's an extended character set, and those define various special characters and graphics characters. Now let's have a look in Delphi, how to write a program that displays the characters for each numeric code. Now, of course, if I've got 256 characters that I want to display, I could define a program with 256 lines that converts each numeric code into each character. But that would be an awfully big programming task, and there's a much simpler way of doing it. Here I'm in Delphi, and this is my solution. This is my entire program. So you can see there's just one procedure, which is the form create procedure, and that creates my entire ASCII table. And here it is. And you can see that I've got, first of all, a number of non-printing characters. Now we come up to number 32. 32 is actually the space character, so you still can't see anything. Then we come on to various punctuation and mathematical characters. At ASCII 48 we're into the numbers, then some more special characters. Then we're on to capital letters, ASCII 65, some more special characters, and then we're on to the lowercase letters, and then we're back up into some of the special characters at the top. Okay, so let me just look at this program that does all this. Here I've set up a for loop. Now what this says is for, and then we initialize the integer variable to 0. So what this says is I equals 0 at the beginning of the loop, and we count through the values of I one by one, incrementing the value at 1 through each step through the loop until it equals 255. So 0 to 255 corresponds to the ASCII codes, and that's actually 256 characters, because 0 obviously adds on an extra. If we started at 1, it'd be 255 characters, but we're going from 0 to 255, so that's 256 characters. Then all I do is I add this line of text to the list box. It's a string. It says ASCII plus int to stri. So initially that will print 0, then on the second time through the for loop it will print 1, on the third time 2, and so on until it comes to 255. Then this next statement at the end, chr, that's a function that converts I to its character representation. So int to str converts an integer to an integer representation. So if it's 65, for example, int to str will just show the string 6 and 5, but chr converts it to its character representation. That is the character that is found, that is represented by 65 in the ASCII table, and that happens to be a capital A. There's another function which is related to chr, and that's called ord. So let me explain those. Chr 65 returns capital A. Ord does the reverse operation. Ord capital A returns 65. So just bear in mind, if you need to convert integers to characters and characters to integers, those two functions are invaluable. Now let's run it again, just to see it in action. So you can see, let's just see, I just mentioned 65. So 65 is indeed the character capital A. So that's my ASCII table implemented in just this single for loop, just a few lines of code. Let's quickly look at it, the same program in Lazarus. Now I want to run this first to show you a little problem. So here all is well, the non-printable characters at first, numbers and alphabetic characters, they're all fine, but we're not getting anything shown at the upper reaches of the so-called extended ASCII table. That's because, as I mentioned earlier, UTF-8 is the character encoding that is increasingly becoming standard these days. UTF-8 has a much, much bigger character set, and it can represent all sorts of international characters, in addition to the relatively small number of characters defined by the ASCII table. And Lazarus requires UTF-8 encoding to display the full set of characters. So in my Lazarus version of the program, I've added this UTF-8 encode function to convert the character in this alternative line. So when you run it, try commenting out the line up here, uncommenting the line down here, run it again. And let's have a look at the upper ranges. And this time you can see that the full range of characters have been displayed. Here I've written an improved version of my ASCII table. In this version, I've decided to ignore completely anything with a code lower than 32. Those are the special characters, things like backspaces and other non-printable characters. So number 32 is the space character. I've decided to categorize each character in a certain way. So 0 to 9, I've called number, and I've printed the string number before the character code and the character itself. Those characters that are alphabetic characters, capital A to capital Z, I've called a letter. And later on in the code, also the lowercase a to Z. And that leaves a whole load of other characters, things like exclamation marks and various mathematical operators, and here these other characters, equal signs and semicolons, and at the top end of the table all these various special characters. And all of those that are not either numbers or alphabetic characters I've just called special. They're something else. Let's look at the code. I've still got a simple for loop for I equals 0 to 255, so that iterates through a loop starting with a value of 0 and ending with a value of 255. At each turn through the loop, I has that numerical value, 0, 1, 2, 3, 4, etc., etc. The value of I is incremented by 1 each time the loop executes. Now what does this do? I do a test. So first of all, I'm ignoring anything lower than 32. So my first test says, if I is greater than or equal to 32, and I is less than or equal to 47, and these operators test greater than or equal and less than or equal, or I is greater than or equal to 58, and I is less than or equal to 64, or I is greater than or equal to 91, well, etc. I'm not going to read through the whole lot. But anything that is within those range of values is categorized as special. Else. So else, if those values are not met, then if I is greater than or equal to 48, less than or equal to 57, then it's a number. So the numbers in the ASCII table are all in one bunch. The letters are not all in one bunch. The lowercase and the uppercase are in different sections of the ASCII table. So I've got another else test. If it's greater than or equal to 65 or less than or equal to 90, well, and so on, you can read through that to make sense of it. Now, I want to talk a bit about the and or tests. And or are Boolean operators. In order to return true, the tests on both sides of and must be true. In order to return true, either one of the tests on either side of or must be true. So, if I test a true and true value, I return true. If I test a true and false value, I return false because both sides of the and must be true. If I test true or true, it returns true. If I test true or false, it returns true, because either one value on either side of the or test must be true in order to return true. So bear in mind that true and false returns false, true or false returns true. So this code works, we've verified that it works, but it's really hard to understand. If you look at that, I'll read through it again in English. What this says is, if I is greater than or equal to 32 and I is also less than or equal to 47, or if I is greater than or equal to 58 and I is also less than or equal to 64, or if I is greater than or equal to 91 and I is also less than or equal to 96, or if I is greater than or equal to 123, then execute the next bit of code. I mean, it's far, far, far too complicated. So there's a simpler way to deal with this kind of complicated test, and we look at that next.